Hi. Yeah, so I'm in my first year of my PhD in the University of Portsmouth, although it's a bit of a collaboration of 3 universities. So most of us here, I'm sure, are well known and acquainted with the Burgess Shale. It's a very famous fossil Lagerstätte that's located in the Canadian Rockies of British Columbia in Canada. It's probably best known for its exceptional fossil preservation of soft-bodied organisms and those insights then that it's provided into the Cambrian explosion. So meaningful evaluation of the ecological and evolutionary significance of the Burgess Shale fauna relies a lot on taphonomic factors and the processes that involve trying to find these out. So taphonomic processes including pre-burial and post-burial transport. So with the Burgess Shale fauna, there's 2 competing hypotheses on how the transport involved the entombment of these organisms. So it was first originally interpreted as distal turbidity currents, in which the creatures were caught up in a cloud of sediment and then transported downslope from one environment to another and deposited, buried within this cloud of sediment. However, more recent analysis on the degree of disarticulation of these fossils have argued that, in fact, it was minimal transport and the creatures were actually living close to the environment of deposition, or in fact are fossilized within the sediment that they were living on. So, considering the importance of the Burgess Shale, it's an important question to ask of which one of this pre-burial transport was it. So that's where my project is involved, or trying to constrain transport distances on the Burgess Shale fauna. So first of all, the analogue organisms that I've decided to use is a Polychaetes nares worm, as well as a Crangon arthropod shrimp, both representing quite a large proportion of the Burgess Shale fauna in terms of body plan and structure. So both these organisms then will be tested in my washing machine. It's an annular flume tank, which I'll try and play for you. You can see how it actually moves. That's just the bottom, the top spins as well. But so basically what I'm doing is I'm putting these analogue organisms into the annular flume tank and testing whether or not the survivorship of when they're subjected to prolonged transport regimes of turbulent, laminar and transitional flow regimes, and seeing whether they survive or not and keep in whether they disarticulate or not when subjected to these different types of flows. So I've first of all set up experiments with just water and the Polychaetes. Second phase involves realistic sizes from the Burgess Shale of grain size analysis and putting sediment into the tank, and then at the end mud, sediment and water. So for initial experiments I tried with seawater and the Polychaetes, and I was supposed to be showing you guys the results I found of what happens to the Polychaete when it's subjected to a highly turbulent flow just involving seawater. However, I did do this and I subjected it to a highly turbulent flow according to Reynolds number, but unfortunately due to recent updates of the tank of man-made equipment, my worm did disarticulate, but this is what happens to it when it gets in the way of equipment that shouldn't be there and gets mangled in the equipment. So that's my results so far. So in the meantime, I've been experimenting with different euthanization techniques to see what works best in terms of what's basically not causing any harm to the Polychaete worm, which I find anoxia is probably the best, although it does take some time for the poor thing to actually die. But for future plans, so I'm going to the Burgess Shale site this summer to hopefully characterise the variation across the deposits, as well as the extent of grain size analysis, and then feeding this back into my experimental design, modifying the flume tank so my experiments will work without any problems of the poor worms being caught up, as well as creating an indices of disarticulation then to compare the disarticulated or not disarticulated analogue organisms to the Burgess Shale fauna. So that's it.